sequences and series. Okay. An arithmetic sequence has first term 5 and common difference 3. Find the 20th term. Okay, to find the 20th term, you have to do 5 plus 19 times 3, which is 5 plus 57, which is 62. So 62 is the 20th term in the arithmetic sequence, beginning with 5 and with a common difference of 3. An arithmetic sequence has third term 11 and seventh term 27. Find the common difference. Okay. So the common difference would have been added on 4 times to the third term, and the difference between 27 and 11 is 16, and thus the common difference itself must be 4. So the common difference is 4 for the arithmetic sequence whose third term is 11 and whose seventh term is 27. An arithmetic sequence has a first term of 100 and a common difference of -7. What is the first negative term? Okay. All right, let's think about this. All right, so the 15th term is 2, and the 16th term is -5. So the answer is the 16th term. So for the arithmetic sequence beginning with 100, whose common difference is -7, the first negative term is the 16th term. Is 61 a term of the sequence beginning 4, 9, 14, and so on? This is an arithmetic sequence whose common difference is 5. And we can clearly see that the units alternate as 4 and 9. And therefore, 61 is not a term in this sequence. So 61 is known in the sequence starting 4, 9, 14, and so on. An arithmetic sequence has a first term of 2 and a 10th term of 29. What is the common difference? Okay. So to reach the 10th term from the first term, you have to add on the common difference 9 times. And to go from 2 to 29, you have to add on 27, and therefore the common difference is 3. Three is the common difference of the arithmetic sequence whose first term is 2 and whose 10th term is 29. Okay, now series. Find the sum of the first 20 terms of the arithmetic series whose first term is 3 and whose common difference is 4. Okay, so we are going to use the formula n over 2 multiplied by 2a plus n minus 1 times d. Okay, so we go inside the bracket first. So 2 times 3, which is 6, and then 6 plus 19 times 4. 19 times 4 is 76. 6 plus 76 is 82. And then 82 has to be multiplied by something. Hello. All right. Let's see now. 82 has to be multiplied by 10, so it should be 820. Although that doesn't quite seem correct, so I have to check. Okay, so that formula is correct. It's n over 2 multiplied by 2a plus n minus 1d. So that's fine. Okay, next. Find the sum of the first 50 positive integers. So we can use the classic argument of pairing 1 with 50, 2 with 49, 3 with 48, and so on, until we get 25 pairs, each evaluating to 51, and then multiply 25 by 51. Okay, so that should be 1,275. An arithmetic series has a first term of 7 and a common difference of -2. Find the sum of the first 12 terms. Alright, so we have to use the formula again, which says that the sum of the first n terms is n over 2 multiplied by 2a plus n minus 1 all times d. And in this case, a is 7, d is -2, and n is 12. Alright, so we go inside the brackets first. So we have 14 plus 11 times negative 2. So 14 plus negative 22, which is negative 10, and then negative 10 has to be multiplied by 6 to get negative 60. So negative 60 should be the sum of the first 12 terms of the arithmetic series, which begins with 7 and has a common difference of negative 2. The sum of the first terms of a series is n squared at 3n. Find the fifth term. So we're not actually told what kind of a series it is. Okay. Alright, and maybe we don't need to have that told to us. Instead, we can just input 1, 2, 3, 4, and 5. Alright, so inputting 1, we get 4. Inputting 2, we get 10. And inputting 3, we get 18. So it goes 4, 10, 18, and thus it begins 4, 6, 8, and so we can see that it's the even numbers beginning with 4. So it goes 4, 6, 8, 10, 12. So 12 would be the fifth term in the arithmetic series, rather 12 would be the fifth term in the series whose sum of the first n terms is n squared plus 3n. Well, let's try that again. An arithmetic series has 13 terms. First term is 4, last term is 40. Find the sum of the arithmetic series. So we will use the formula. The sum of the first n terms of an arithmetic series is n multiplied by the mean of the first and last terms. Okay, so it has 13 terms, and the first and last terms are 4 and 40, and their mean is 22, and thus the answer becomes 13 times 22, which is 286. So 286 is the sum of the arithmetic series having 13 terms and whose first term is 4 and whose last term is 40. Next up, geometric sequences. A geometric sequence has a first term of 3 and a common ratio of 2, so find its 8th term. We use the formula that the nth term of a geometric sequence is the first term multiplied by the common ratio to the n minus 1. So in this case, that would be 3 multiplied by 2 to the 7, and 2 to the 7 is 128, so 3 times 128 is 384. So 384 is the 8th term in the geometric sequence whose first term is 3 and whose common ratio is 2. A geometric sequence has second term 6 and fourth term 54 and a positive common ratio. Find that common ratio. So 6 would have to be multiplied by the common ratio twice to get 54. So 6r squared equals 54. So r, the common ratio, is 3. In the geometric sequence, which begins 81, 27, 9, which term is equal to 1? So this is clearly the descending powers of 3, beginning with 81. So continuing on, it would go 81, 27, 9, 3, and 1, and thus the answer is the 5th term. The first term of this geometric sequence is 81, and the common ratio is 1/3. Find the positive geometric mean of the numbers 4 and 25. To do so, you multiply the numbers together and then find their square root. The product of 4 and 25 is 100, and the square root of that is 10. So 10 is the positive geometric mean of 4 and 25. The geometric sequence has a first term of 5 and a common ratio of -2. Find its 5th term. Yes, that's right. Okay, so to do so, we're going to use the formula that the nth term of a geometric sequence is the first term multiplied by the common ratio to the power of n minus 1. So in this case, it would be 5 multiplied by -2 to the power of 4. And -2 to the power of 4 is 16, and 5 times 16 is 80. So 80 is the fifth term of the geometric sequence whose first term is 5 and whose common ratio is -2. Alright, now geometric series. Find the sum of the first 6 terms of the geometric series beginning 1 plus 2 plus 4 and so on. These are the ascending powers of 2. So although we could use the formula, it's more elegant to note that this has a special property associated with it. And we can see it by just observing the sum of the first n terms. Okay. Alright. So it is find the sum of the first 6 terms of the geometric series beginning 1 plus 2 plus 4 and so on. So when we observe, we see 1, 3, 7, 15, and so on. And so clearly these are the powers of 2 minus 1. And so the 6th term should be the 6th power of 2 minus 1, which is 63. Okay, a geometric series has a first term of 3 and a common ratio of 2. Find the sum of the first 5 terms. So, again with this one, we could proceed by brute force. And we will do so, and then check it potentially by the formula. So the first 5 terms in this series are 3, 6, 12, 24, and 48. And then we can add those together. So we get 21 plus 24, which is 45, and 45 plus 48 is 93. So 93 is the provisional answer, and then we can use the formula as well. And the formula states that for the first n terms of a geometric series, you multiply a by 1 minus r to the n, and then divide it by 1 minus r. So in this case, it would be 3 multiplied by 1 minus 2 to the 5. So 3 multiplied by -31, which is -93. And then that has to be divided by -1, which would be +93. So we confirm the result. Find the smallest n for which the geometric series 1 plus 3 plus 9 and so on exceeds 400. Alright. So this is a geometric series whose first term is 1 and whose common ratio is 3. And so looking at the formula and setting it equal to 400, we have 3 to the n minus 1 over 2 equals 400, so 3 to the n minus 1 equals 800, so 3 to the n equals 801, and then log base 3 of 81 to find the value of n, and that should be 6 point something, and so the answer would be 7. Okay. A geometric series has a first term of 16 and a common ratio of a half. Find the sum of the first 5 terms in the series. So with this one, we can proceed by brute force, which would state 16 plus 8 plus 4 plus 2 plus 1, which is 31. And that's sufficient. A geometric series has a first term of 2 and a common ratio of 3, and the sum of the first n terms is 242. Find the value of n. Alright, so we're going to use the formula, and we're going to say that 2 multiplied by 3 to the n minus 1 over 2 is equal to 242. We shall cancel the 2 on the top and the bottom to get 3 to the n minus 1 is equal to 242, and thus 3 to the n is 243, and thus n is 5. Okay, next up is sum to infinity. Just a second. Find the sum to infinity of the series whose first term is 8 and whose common ratio is 1/2. The formula in this case is that for a geometric series whose common ratio has an absolute value that is less than 1, the sum to infinity is the first term of the series divided by 1 minus the common ratio. And thus, in this case, we just have to do 16 over 1 minus 1/2. In other words, 16 over 1/2, which is 32. Find the sum to infinity of the geometric series whose first term is 9 and whose common ratio is -1/3. So we have to just do 9 over 1 minus -1/3, which is 9 over 1 plus a third, which is 9 over 4/3, which is 9 times 3/4, which is 27 over 4. That's the sum to infinity of the geometric series whose first term is 9 and whose common ratio is negative a third. A convergent geometric series has a first term of 5 and a sum to infinity of 20. So, find the common ratio. Alright, so applying the formula, we have that 20 equals 5 over r minus 1. Okay. And then rearranging, we have that r minus 1 is equal to 5 over 20. So r minus 1 is equal to 1/4. So r should be 1 and 1/4, which is not possible. So we'll try again. Okay, so it says a geometric series has a first term of, a convergent geometric series has a first term of 5 and a sum to infinity of 20. So find the common ratio. Alright, so 20 is equal to 5 over 1 minus r. Okay, so 1 minus r is equal to 1/4. Alright, so r is simply 3/4. Yeah. State the condition on R for a geometric series to converge. R, or the common ratio, has to have an absolute value that is less than 1. A geometric series has common ratio R being 1/3 and the sum to infinity being 12. Find the first term. Alright, so looking at the formula, we have 12 equals A over 2/3. So now 12 multiplied by 2/3 should give us the first term, and the answer to that is 8. So 8 should be the first term of the convergent geometric series, whose common ratio is 1/2. See if we can get it. No, that's lost. Oh, I see. Okay, so 8 is the first term of the convergent geometric series whose common ratio is 1/3 and whose sum to infinity is 12. Oh, new chapter, sigma notation. Okay. Sigma r equals 1 to 10 of 2r plus 1. So we can rewrite this as 2 multiplied by the sum of r ranging from 1 to 10 plus 2 times the sum of just 1 itself ranging from 1 to 10. Now the latter part is clearly 20 and the former part is twice the 10th triangular number, and the 10th triangular number is 55, and thus it becomes 110 plus 20, which is 130. Okay. Find the sum of the first 5 terms of 3 times 2 to the r minus 1. Okay, so we can factor out the 3, and then we need only find the sum of the first 5 terms of the powers of 2 beginning with 1. So 1 add 2 add 4 add 8 add 16, which comes to 31, which must then be multiplied by 3, which gives 93. So 93 should be the answer to sigma ranging from 1 to 5 of 3 times 2 to the r minus 1. Evaluate sigma of r ranging from 3 to 20 of 5. Okay, so if sigma ranges from 3 to 20, then this means 18 terms in total, and all terms are 5. And thus, we just do 18 multiplied by 5, which is 90. So 90 should be the sum of the sum of r ranging from 3 to 20 of just 5. Evaluate the sum of r equals 1 to infinity of 1/2 all to the r. Okay, so this is evaluating an infinite geometric series. Now, hold on a minute. Alright, maybe I misread it. Oh yeah, okay. Evaluate the sum of r equals 1 to infinity of 1/2 all to the r. Okay. So this is a geometric series whose first term is 1/2 and whose common ratio is 1/2. And it's a convergent geometric series as the absolute value of the common ratio is less than 1. Okay, and so next we have to do 1/2 over 1 take a half, which should just evaluate to 1. Next up, evaluate sigma r equals 1 to 12 of 3r minus 2. So we can split this into pieces. So it's 3 times sigma 1 to 12 of r minus sigma 1 to 12 of 2. And in the first case, we need the 12th triangular number, which is 156 over 2, which is 78. And 78 has to be multiplied by 3. 78 multiplied by 3 is 234. And then we have to do 234 minus 24, which is 210. All right, chapter 7, recurrence relations. Given the recurrence relation, un plus 1 equals 2un plus 1, and that u1 is equal to 3, find u3. Alright, so in this case we can just simply run the program. So it simply says double the previous number and then add 1. So 3 becomes 7, and 7 becomes 15. Given the recurrence relation, un plus 1 is equal to un plus 4, and that u1 equals 2, find u10. This is simply saying, given the arithmetic sequence whose first term is 2 and whose common difference is 4, find the 10th term. So we simply have to do 2 plus 4 times 9, which is 38. Given the recurrence relation, un plus 1 is equal to 3 minus un, and u1 is equal to 1, find u50. Alright, so let's think about this. Okay. So how will this start? Well, it will go 3, then 2, and it has to be 1, and then 0. So in other words, it's counting down from 3. But the very first term is 3. Alright, so how we're going to do this? So what you have to do is you have to negate the nth term, or rather you have to negate n, and then you have to simply add 4. So in this case it would be negative 46. Given that un plus 1 is equal to half un plus 3 converges to a limit L, find out what L actually is. Okay, so you simply now you have to continuously half the previous number, no matter what you do. But then you have to add 3 to it. So I think that it converges to 3. Given that un plus 1 is equal to un all squared minus 2, and u1 is equal to 2, I'm going to have to try again. Given that un plus 1 is equal to un all squared minus 2, and u1 is equal to 2, find u4. So we have to square the previous number and then subtract 2. So it will begin 2, then 2, then 2, then 2. Oh, it's sort of stuck in a cycle, so 2. Okay, this should be the last one now. Modeling with series. A salary starts at £20,000 per year and rises by £1,000 with each year. So find the total amount earned after 10 years. Yes, that's right. Okay, so we just need to find the 9th triangular number, which is 45, and then do 20 multiplied by 10, so £245,000. car worth £20,000 depreciates by 20% per year. Find its value after 3 years. So we can proceed by brute force. So at year 0, it's worth £20,000. After year 1, it's worth £16,000. After year 2, it's worth £12,800. And after year 3, it's worth £10,240. Logs are stacked with 20 on the bottom row and 1 less on each row above, culminating in the top row with only 1 log. So find the total number of logs. That would be the sum of the positive integers from 1 to 20. We apply the classic technique of pairing 1 with 20, 2 with 19, 3 with 18, and so on until we have 10 pairs, each totaling to 21, and thus summing to 210. A person saves £5 in week 1 and £2 more in each subsequent week. In which week do they save more than £50? Alright, so the first term is 5, the second term is 7, the third term is 9, and so on. So it's asking, when do we reach 51? Alright, so what you do is, okay, so let's see here. So 2n plus 1 gets you the nth odd number, and then you just simply have to add 4, so it would be 2n plus 5. So 2n plus 5 is equal to 56, and therefore in the 28th week it will exceed £50. A ball is dropped from a height of 12 meters and rebounds to a height 1/3 of its previous height each time. Find the total distance traveled. Alright, so this is sort of a trick question, but we're going to try anyway. So we're going to do 12. Beg your pardon? 1/3. Yes, 1/3. Okay. 12 over 2/3. And that would be 18. So we have to multiply 18 by 2, in fact, and then also subtract 12. So it would be 24 meters. And that completes it. And boy, oh boy, did that